In the previous video, we've seen what it means to have one vector adding another vector. So if you have this vector v here and u here, if you add the two vectors, it would simply be this plus this. That would give you your first component. This plus this, that will give you your second component, and so on. That will give you this component. So now we're going to look at what it means to have a scalar times a vector. So a scalar times a vector, if you have, let's say, a number 3 here, and then you times a vector, then you simply get this number times this, times this, times this. That will then give you this. So now let me try and illustrate this to you, but in 2D, so that you can get an idea of what's going on. So now I'm going to illustrate this. So let's say you've got a vector v. Let's say you've got a vector v. This vector here is v. This one here is u, and then this one here is w. So w is actually going 2 across and then 2 down, -2. So let's look at v. Let's just look at v. What does it mean to have, let's say, 3? Let's say 2v. What does it mean to have 2v? Well, 2v means u. Well, one v would mean moving from here to here. Well, 2v would mean u doubling the magnitude in the same direction. So that would then take you from here to here. Okay, so 2v would mean doubling the magnitude in that direction. So it would take you from here to here. So now 2v would mean this. Well, v would be 2 across, and then 1 up. So that would be 4, and then that would be 2. So look at this: 4 across, 1, 2, 3, 4, and then 2 up. 1, 2. So have the same effect. So you simply do this times this and this times this. And if you think about it, you doubling the magnitude in that same direction you can think of it as you doubling this, doubling the horizontal direction. So doubling this, so it's 1, 2, and then doubling the height, 1, 2. So that will have the same effect as you doubling the magnitude in that same direction. So when you simply have a scalar times a vector, v1, v2, v3, then that would be the same as kv1, kv2, and kv3. That will have the same effect. And something else I want to illustrate to you is that you can actually do this. You can actually say 2v. So that will then take you, that will then take you to here, and then so w is in this direction here, but I want to minus w, the vector w. So normally w would take me down here, but minus w would go in the opposite direction. So I can actually do this, minus w. So that would then take me to here, because normal w would be you going downhill. But then the minus version would be you going the other direction. And then you could actually do this as well. You could actually minus v. So you could, in effect, you could actually minus 3v if you wanted to. So minus v would then take me to here, because v is going uphill. So normal v would be here, but I'm minusing 3v. So that would then take me to here, and then minus another 3v, that would then take me to minus another v, that would then take you to here, minus another one, that would then take me to somewhere down here, and so on. So you can actually add and take away all these factors. Okay.